Now we get into a topic called iterators. And uh, iterators make STL data structures a lot easier to use. So I'm going to introduce you to iterators. Uh, I want you to know the difference between stuff that's in all programming languages and the stuff that's just in C++. So iterators are really, as far as we're concerned, they're a C++ specific topic. But really, a lot of programming languages have some equivalent of iterators. It's just that really in any programming language you can do data structures, but iterators are kind of a C++ thing with STL to really make these a little bit easier to use. So let's go back to our lists and our, let's say, vector, because we really want to talk about the dynamic version. So in our list, in our linked list, we should say, what would happen is we would have a piece of memory and then a piece of memory. And I'm putting spaces because there might be a bunch of memory in between. These might be right next to each other. We don't know. So I'm putting spaces. And as I said before, we have these arrows that kind of go from one to the next, and we have to bounce. And I kind of glossed over how exactly we go from one to the next to the next, and let's just put some numbers in here. We'll say 1, 2, 11, 7, and 6. So we've got some memory regions, and there's some stuff in between. Let me just scribble a little bit so we understand that these are separated. There could be a lot of memory in between. These things could be right next to each other. The point of the list is that we don't really care. We just have the next available memory region. And then we have our vectors, and with our vectors, those do have to be one right after the other. And then when it fills up, we copy it over, but even after we do our copy, there's still one right after the other. Let's just put some more numbers in here. 2, 1, 4, 6, 9, 11, 17, 33, and then 3. That's fine. So we can, as you saw previously, there's something called operator overloading, and I kind of waved my hands a little bit and cheated, because you can use a vector basically the same exact way as a traditional array, but so say I wanted to get to the third element, I wanted to get to this one right here, and then say we had one called my vector. So this would be 0, 1, and then 2, because we count from 0. So I'm going to say my vector 2. And then if we wanted to get to my vector 2, we would just do that. Say we want to access this guy right here, this second element in this list. We can't really use this. They haven't, well, in the Visual Studio implementation of STL, maybe some other people have done some operator overloading where you can just use this syntax, but we can't just do that with a list. We can't just say my list 2. What we have to use is something called an iterator. And basically what an iterator does is it goes through these one at a time, and we don't have to worry about what it actually does in the background. And so I hope that makes sense. So let's just kind of draw out what happens with an iterator. So say I've got a vector of ints. Call it my vect. And say we've done a bunch of pushbacks. Let's say I'll just scribble. Let's say we added a bunch of data. And now we want to go through that data. And so what we'd actually do is we would use something called an iterator. And so the way you use an iterator And I'll do this in Visual Studio in a little bit, but I wanted to do it on the kind of the drawing pad so I can draw arrows and notes and do other little things. So we're going to say, again, we're going to say a vector of ints. Then we use some more, and these are colons. So you do 2 colons, and then we say an iterator. And then we'll just say iter. That's a pretty common abbreviation. And so what happened? Well, vector knows how to go through each of these. If we had done list, we could have just as easily done a list iterator. And within these iterators, it knows the internals of how to move through this thing. We don't have to get caught up in pointers and where the next node is, and if the memory is contiguous, we don't really even have to know very much about the internals of a list or a vector. It helps because we want to know which one is more appropriate for our situation, but we really don't. And then what you do is you move through it in a for loop. So then our typical usage would be you do for, you'd say iter equals, then we go back up to myVect and we say myVect dot begin. So that's our initial part. And then while the iter is not equal to the end, so initially we're setting, when we do myVect.begin, we're setting it to this thing, and we don't have to worry about the internals. Vectors and iterators know how to handle all that. And then while we're saying, and then our middle part of the for loop is we're saying while the iterator is not equal to the end, and then we say, let's go back to orange, say my dot end. So while we're not at the end, and then we can use a little bit of cheating. We can use some of this operator overloading that we've talked about. We're just going to say iter plus plus, and we don't really care. And then we can use pointers, and I'll show you how to do that. But we have some stuff in the middle. But that's essentially how you use it. So you've got your data structure. This could just as easily be a list or a vector. And you add a bunch of things, and you have a populated list or vector. And then you create something called an iterator. And the iterator knows how to actually move through that. So we don't have to get caught up in the implementation specifics of any of this. If somebody created a brand new type of data structure that we had no clue about, but we just knew it was really fast and really useful for our situation, we could just as easily use it and move through it using our iterator. And so we say that the iterator equals the beginning of the data structure. So in the vector it's here, but if we were using a list, it would be right here. And then while it's not equal to the end, so this would be the end on the list, this would be the end on our vector, and then we say plus plus. And this plus plus is, again, as I mentioned, something called operator overloading, but basically it's saying go to the next part. So in the list, it's going to go from here to here to here to here. In the vector, it's just going to move through these one at a time. And then we'll have some code in the middle, and I'll show you that code in a little bit. But hopefully that makes some sense. Don't forget, this is a very C++ centric thing. This is a C++ topic. It's actually really specific, not just C++, but STL specifically. So STL is a part of C++. And it will make, I know it seems a little complicated now, it'll actually make these things way easier to use because you don't really have to know the internals and the implementation specifics of these things. You can just kind of blindly use an iterator.